Okay, so quadratics number 17. We're going all the way to 22. There's only 5 left. Fair enough? And then we're going to be done with quadratics for the entire school year. And if you snap your fingers, everybody snap your fingers? For most of you, you're going to be juniors, I think, in the room. Right? You excited about that? It's very close. You're going to be juniors very soon. All right, and congratulations on that. Okay, so back to quadratics. Do you know what a quadratic is? Can you think of something in your mind? Don't stop what you're doing right now. Are you closing your screens so I can have your attention? Are you closing your screens? Dennis, are you with me? Please and thank you. Are you going? Aiden, are you with me? Are you closing your screen? Andres? You're going to make me say all your names individually? Okay, close your screens. All right, good. Okay. Think in your mind right now. What's a quadratic to you? Something's got to come in there. I want something to come into your mind.
4.
Think of something. Okay, somebody yelled out 4. Somebody yell out something else. What else are you going to yell out for quadratics? Your brains start to think as all your brains think. Do you know this? You're like a network. One person says 4, quadratics. What else? What else you got? Foil. What else? A math statement. What else? What's FOIL mean? Good. What are you using FOIL on?
For multiplication steps. Oh no.
Good.
On a binomial. Polynomial.
Good, good, good. In a lot of ways, none of you are wrong, right? There's almost, you're starting to go down the road of all the vocabulary of quadratics, right? Can your brain start to piece together all of it together in some sort of coherent pattern next, right? Because I know you can do this, right? You can start to bring up everything on quadratics, and this is what you do. You force yourself, you guys study for tests all the time. You don't know what's on the test. You start to review the material. Then you ask yourself, what have I studied, right? And you start to go, what have I really put in here? Did anything stick, right? And you know that a lot of material is not that sticky, so it's hard for you to get it to stay in there, right? But that's part of what school is. You're trying to do some of this. So in later in life, when you find things that aren't so interesting, at least you can engage in them, okay? So anyway, let's go down with quadratics. Let's start with an example. And I'm going to show you a factoring method called completing the square. What is completing the square? Everybody say completing the square. What is a square? Okay, take your finger in the air and draw a square. Yes, it's a shape. What is it in algebra?
What happened?
What is it in algebra? What's a square in algebra? Exponent, good. See, go, keep going, right? Exponent. What is a square in algebra? What kind of exponent? 2, power 2, right? Okay, so here's what I've got here. There's some interesting things going on. Let's start with a quadratic, which is to the power 2, and let's talk about a factoring method called completing the square. Completing the square is adding b divided by 2 squared to both sides. That doesn't make much sense right now to you, but we're going to show an example and explain that. So here's the first example. F of x equals x squared plus 6x minus 27. We're going to factor this. Factoring is the opposite of what? Factoring is the opposite of what? Kind of yes, and kind of yes. So remember, go back, always we try to go back to some foundational place, right? What's an operation in math?
Oh, like
Multiplication, addition, what else?
subtraction.
Good, good, good. Those are operations. For every operation, there is a forward and a backwards, right? Forward and a reverse. If the opposite of addition is,
Subtraction.
right? This is math. This is the basis of everything. Everything goes back to this all the time. You hear us start here and we start to build from it, right? What's the opposite of multiplication? Okay? And then Then we get into the distributive property and factoring. Factoring is where we reverse the multiplication steps that you guys were talking about. FOIL, there's 4 steps that produce this to make a trinomial, which Natalia mentioned. Here's your trinomial. We multiplied 2 binomials to get this. We're going backwards now to get back to the 2 binomials we started with in the first place. You with me? So this is like a division process. We're going backwards. Backwards. All right, backwards is always harder than forwards. So here's how this method works. Remember before when we factored, we would just start drawing the binomial. We would put in x and x to get x squared, and we would try to figure out what the other terms and the signs were in there to factor this. Now we're going to use a deliberate method where we go through the following process. We take this and start to split it into 2, and we move this to both sides. I'm going to try to keep it like the notes, so when you guys do the notes, it makes sense to you. X squared plus 6x. And to do this, if I had written this the way I would have liked to have seen it written, I would have said this was equal to 0, because now I want to move the 27. I'm going to add it to both sides, so I'm going to move it to the right of the equation, and I'm going to get a positive 27 over here. So all I've done is taken the equation, and I've added 27 to both sides. It shows up on the right side of the equation now. Okay? Then we're going to do this completing the square method. All right, we're going to come down here and we're going to take b, divide it by 2, and square it. When you're looking at this here, what is b? What is b in this case? You're very tentative about it, but that's it, right? B is 6. You remember this? Remember the pattern of a times x squared plus b times x plus c. And these a, b, and c now get played into because we're dealing with this here. So b in this case is 6. So we're going to take 6, divide it by 2, which is what? Then we're going to do comma. We're going to take 3 and we're going to square it. What do you get? 9. And we're going to add this to both sides. So adding b over 2 squared to both sides. See that right there? We took b, divided it by 2, we squared it. Now we're going to add it here, and you're going to get a plus 9 and a plus 9. Good? What does that do for us? It sets up a factoring of this right here. That is the difference, or not difference, but the 2 squares factoring method, right? So now factor this side. You got 2 parentheses to get your binomial. We're going to have an equals, and then we're going to have something going on over here. 9 plus 27 is 36. Like this. Let me see. Let me stick to the way the notes are doing it too. Good. Good, good, good. Start to factor this. What do I need here and here? Good. What am I going to multiply to get 9?
3.
Good. Positive or negative?
Positive.
Plus 3. See how easy it is when it's a perfect square. Now do you see what completing the square is referring to? So kind of a complicated name. I'm not sure I like it much, but I get, once I see it, I get why they named it that. Okay, so this completing the square takes a square and adds it to both sides and then makes the factoring on the left easier. So what is x plus 3 times x plus 3? This can be rewritten into this format. X plus 3 is now squared equal to 36. Is that okay with you? Do you see what we're doing there? There's 2 of them. So I can just put them together and square them. You okay with this? Because that means this one times this one. Is this okay? Give me confirmation if this is okay for you. This is an okay step. Okay, okay. Because there's 2. And that means I'm raising it to the power 2. Just means 1 multiplied by itself, right? All right, come over here so you can see it better. X plus 3, if this is squared, equal to 36, I'm going to take the square root of both sides because I want to reverse the square out. Once I take the square root of both sides, I need enough room in here to put a plus minus, and I'll go back and remind you about that in a second. Okay, if you don't remember that part of this. The square root of a square leaves you with x plus 3 here. On this side, the plus minus stays in there. What is the square root of 36? I'm going to subtract 3 from both sides, and I'm going to get x equals negative 3 plus minus 6. Good, okay. So I'm just seeing how I did it in the notes. I did a little bit differently. What is negative 3 plus 6? What's negative 3 plus 6? What's 6 minus 3? Are you saying 3? Okay, that's one answer. What's negative 3 minus a 6? Negative 3 minus 6? Close. 6 plus 3 is?
9.
Good. Thank you. Good self-correction. Good. Thank you for participating, and thank you for self-correcting, right? All that's important. We do that as humans, right? Okay, you guys got to let yourself do that. You've got to, right? It's very important. All right, so 2 answers. What did we just find right here? What's the graph of a quadratic? What graph shape does a quadratic make? Draw it in the air. Okay, good. What did we just find here with x equal to 2 things? There's 2 answers, x equals 1, x equals the other, right? What did we find? Close. One of them's right. X intercepts. What's another name? Roots. What's
Zeros.
one? And zeros. Oh, everybody go, oh. Everybody say root. And nice. Say roots, zeros, and x intercepts, right? Do you see how these lessons keep going back through sort of the same topics every day, right? We've been on this every day for about 2-3 weeks, whatever it's been, right? And it's the same thing. You're going through it sort of from a different perspective. You're like going around the thing, looking at it this way. Now let me look at it this way. Now let me look at it this way, right? Each time, hopefully giving you some different perspective on it, right? So what have we done here? We have found the roots. We have factored this. We have factored this quadratic starting here, and if we drop this into parentheses now to create 2 binomials, we would have x minus 3, x plus 9. Why did we reverse the signs of these when we built out the binomials versus the values that x is equal to? Why do we reverse them? What is the rule that allows us to do that? Why do we call these zeros?
Oh, we're doing zero property, right?
Yeah, thank you for that. Thank you. I think that's a more deeper stretch you're going to, is why does this happen, right? We're using the zero property multiplication rule. That's why these reverse on themselves. So x equals 3, yes, but in the binomial, it's got to be represented in the inverse, because we have to take each of these. If this is equal to 0, we have to say x minus 3 equals 0 plus 3 plus 3, x equals 3, right? Check. And same thing here, it's going to reverse when we put it equal to 0, and therefore it's going to be negative 9. You okay with this? Okay, so what have we done here? The completing the square is the interesting part of the process. Let's do it one more time quickly, just so you can see that part again. Let's use x minus 14x plus 48. Let's use this one, and we'll say it's equal to 0 because we want to find the roots. Is that what I got? X squared minus 14x plus 48. Can't quite see it. Okay, let's do just the completing the square process, because that's what you're going to practice in the school G. We're going to move the 48 to the other side. So minus 48 minus 48. X squared minus 14x. It leaves a gap right here. And we have minus 48 on this side. Now we're going to apply the completing the square method. What's b in this case? Negative 14 divided by 2 equals negative 7. Negative 7 squared equals 49. And this gets added to both sides. That's the actual completing the square method right there. So when you practice it, you're going to go back through this same method. So plus 49, plus 49. All right, can you factor this up top here? This one here. 2 binomials equals, what is 49 minus 48? 1. I like that math. What's this one come out? X and an X. Let's do that. What is the what's the perfect square that creates 49? Where 49 is the perfect square. What squared equals 49? Yes, I feel like you guys got to trust yourself more. Yes, you're saying it. You're saying it so quietly. Yes. 7. Now, is it plus 7 plus 7? Because that'll be a plus 49. It's negative. Why? Because when you add the two together, they got to come up with negative 14. So it's got to be minus 7 and minus 7. And then there's 2 of them. So that's x minus 7 squared equals 1. And now you're back to going through this part of the process. Okay, before we do that, let's cover one thing. Why is the square root of 36 need a plus minus in front of it? Square root of 36. What's the square root of 36?
6.
Good. And I'm going to put a plus in front of it, Natalia. And here's the logic. If you take plus 6 and you square it, you get 36. True, check. What's my other answer for the square root of 36? Negative 6. Because, so the other answer, 2 answers, if I take negative 6 and square it, isn't negative times negative positive? And 6 times 6, 36. Check. So there's actually 2 answers created in algebra from the square root of 36. It could be positive 6 times positive 6, or it could be negative 6 times negative 6. Do you follow that logic? So when you take the square root of 36, you have to drop a plus minus in front of it. What does that mean? It means 2 answers. A plus square root of 36, which is 6, and a minus square root of 36, which is minus 6. Does that make sense? When you take square roots of numbers in algebra, you've got 2 answers. You've got the positive set and the negative set. Additionally, right, one last thing, just go to geometry. If you were dealing in geometry and going down this road, this is the difference between algebra. You're in an algebra class right now. Switch back to geometry. If you were taking the square root of 36 in geometry, why does it not have the negative option in geometry? Like, let's say it's a square. So here's geometry now. So this is algebra. You've got this plus minus situation set up. Here's geometry. It's a square. The area is 36. How long is this side right here? 6. Because a square is length times width. You with me? So this is 6, and a square has, I didn't draw it well, but it's the same side here. So 6 times 6 is 36 to get the area, right? Isn't negative 6 times negative 6 still 36? Yes, but why can't I do that in geometry? Why do I not have a negative in geometry when I do in algebra? Maybe. That might be a part of it. Let me ask you this. Can the length of the side of a square be negative 6? What is negative 6? Show me, hold up the length. If I say, show me the length of negative 6 and hold it up in the air with your fingers, what do? And I love what you did. She went like this. What did she do?
Went down.
Went down. Because what does negative represent?
Kind of low.
A direction.
Oh.
If I told you -6 and you went down, you're perfectly within your understanding of what negative means. Negative is not a part of the number. Negative is describing a direction. The 6 is describing a magnitude. The fact remains with a physical shape, like a square, there is no such thing as a negative. It does not exist in the physical world with a shape. Isn't that weird? Remember what happens in math in high school, you guys. It changes from physical to mental. Right? Tell me about a line in geometry. Let's do one example and then we'll be done, because the announcement's any second now. Here, this is geometry. Go back to your geometry. Here it is. What is this? A line. Good. Tell me about the line. That line has got 3 characteristics in geometry. You ready? It's perfectly straight. That line is perfectly straight. Can you see it in your mind? Is there any physical example in this world of a line that is perfectly straight?
Yes. No. I don't know.
Put the yet on that.
I don't know yet.
Don't take this the wrong way, but I love you when you say that, okay? I don't know yet, okay? That's the important part about your brain growth, all right? Okay, so the line is perfectly straight. Okay, think of one. Do you have an example in your mind of a perfectly straight line? Like, look at the edge of the desk. Is it perfectly straight? If you look close enough at this line, is it really perfectly straight?
They have the thing is to measure straight lines.
Okay. How about this? Let's go to the next thing. The second characteristic of the line is it's infinitely thin. How thick is it?
Thin.
Real thin. How thin?
Very thin.
Infinitely.
Oh,
Infinitely thin. What's infinite mean?
in
Forever. And it's forever small, forever thin. Does that exist in the real world? I'm telling you, these two concepts of perfectly straight, infinitely thin exist only in your mind. But if they exist in your mind, they exist somewhere. Are you with me? So something about this physical world is very limiting, and somewhere we exist far more powerfully and dynamically in our minds. What's the last characteristic? How far does the line go that way? How far? It's a line. How far does it go that way? And in geometry, you draw it like this, right? What do those arrows mean? How far does it go that way? Forever. How far does it go that way?
Forever.
Forever. Does that exist in our physical world?
Yes. No.
I mean, come up with an example. Try to come up with an example in our physical world of some line that goes that way forever. And that way forever. Oh, by the way, is
The line in the middle of the road.
but you're going like this. That's not perfectly straight.
Oh, but if the world was cut in half and you put it like this, it would be perfectly straight.
You mean if you unwrapped it? You sliced it and you unwrapped it?
Yeah.
Then it would be perfectly straight? Okay. But it doesn't exist in the physical world. Even that process exists only in your mind. What you just did was a mental exercise, right? We can't do that physically. Okay. Anyway, math and everything else important in life starts to exist only in your mind. Only in your mind. If you think about how crazy that is, back in elementary school, you could count. They said 5, and you counted 1, 2, 3, 4, 5. That was physical. You could do it. You could show math physically. Now, you can't do it anymore without your mind. It takes your mind to conceive what we're even talking about. Do you see did you guys watch Star Wars when they would get in the Millennium Falcon and they would hit light speed and they would make that light thing? Okay, this is the difference between elementary math, you can count it and it's physical, and high school math, you just hit light speed. It's only in your mind. So much of your life is only in your mind. Okay, it's different now. So you got to graduate from the old physical world into the new mental world, right? Which is far more exciting for us humans. Far more exciting. Okay, anyway, stop that and let's go